Welcome back, my students. Dr. Uwe here. We are studying physiological characteristics of cardiac muscle. There are 10 physiological characteristics given in guidance. In the previous 3 videos, we studied first 8. Now, in this video, we are going to study the characteristic number 9th and 10th. So, let's begin. No need to write anything. All the notes, my handwritten notes, are in the description of the lecture. So, let's begin with the characteristic number 9th. It states the action potential in a cardiac muscle is prolonged and has a long refractory period. What does this statement mean? Look at here. In x-axis we have time, while as in the y-axis we have amplitude in millivolts. Clearly, this graph is the graph of an action potential in a ventricular muscle fiber. Remember, this is the action potential in a ventricular muscle fiber. What is an action potential? What is an action potential? Right now, we are studying physiological characteristics of cardiac muscle. In chapter 31, we are going to study cardiac action potentials. And here, we will study the action potentials in detail. Clearly? So, for time being, remember, this is the action potential of a ventricular muscle fiber. Clearly, it is ionic basis, and all the questions related to action potential, we will study it in detail in chapter 31. This action potential of a ventricular muscle fiber, it has phases. Phase 0 from here to here is called early depolarization phase. Clearly, phase from here to here is phase 1 called early repolarization phase. Clearly, phase 2 from here to here is called as the plateau phase, and phase 3 from here to here is called the late repolarization phase, and here to here is the phase 4, that's the resting membrane potential. Clearly, now due to the presence of this phase 2, that's the plateau phase, the action potential of the cardiac muscle is 15 times more as compared to the skeletal muscle. So, due to the presence of this phase 2, that is the plateau phase, the action potential of a cardiac muscle lasts 15 times longer as compared to the skeletal muscle. So that was our statement first. The action potential in cardiac muscle is prolonged. Why is it prolonged? It is prolonged because of the presence of this plateau phase. That's the phase 2. Moving forward, now we have this refractory period. What do you mean by refractory period? Consider this a heart muscle. If we give stimulus to a heart muscle, it will excite. Now this excited heart muscle, if we give another stimulus to this excited heart muscle, it will not re-excite because it is already excited by the first impulse. Clearly, so the time period or the time interval during which the normal cardiac impulse cannot re-excite the already excited area of the cardiac muscle is called the refractory period. So refractory period is a time interval during which the second impulse cannot re-excite an already excited cardiac muscle. So that's the refractory period. Clearly, now the duration, the normal refractory period of the ventricles is 0.25 to 0.30 seconds, while as the refractory period of the atria is 0.15 seconds. This 0.25 to 0.30 seconds is quite a lot of time in regarding the heart. So the cardiac muscle has a long refractory period. So this was our statement. The action potential of the cardiac muscle is prolonged and has a long refractory period. Now, regarding this refractory period, we have one more point, that is the types of the refractory period. It has two types. Number first is the absolute refractory period. Number second is the relative refractory period. What is absolute refractory period? Clearly, it is the time interval during which the cardiac muscle does not show any response. If this is a cardiac muscle, if we give impulse to a cardiac muscle, it will get excited. Now, if we use second impulse to a cardiac muscle, it doesn't matter how hard the second impulse is. This cardiac muscle will not re-excite. So that time interval is called absolute refractory period. It is that time interval during which the cardiac muscle do not show any response. So due to the second impulse, the cardiac muscle does not show any response. Clearly, now if we have the cardiac muscle, if we give first stimulus, it will get excited. Now if we give the second stimulus, if we use the second stimulus and the second stimulus is of maximum intensity, the cardiac muscle will re-excite. The cardiac muscle will re-excite. In the normal circumstances, if we give the first impulse, cardiac muscle will excite. Cardiac muscle will excite. Now, if we give the second stimulus, this cardiac muscle does not re-excite. But this cardiac muscle re-excites if we give the second stimulus of maximum intensity. That time period is called a relative refractory period. That means in this time period, the cardiac muscle does show a response if the strength of the stimulus is increased to maximum. Clearly? So this is the relative refractory period. In the absolute refractory period, cardiac muscle does not show any response, but in the relative refractory period, cardiac muscle shows response if the stimulus is of maximum intensity, if the second stimulus is of maximum intensity. Clear? Now another point, in this absolute refractory period, it extends from phase 0 to half of the phase 3 of action potential. Clearly, this right here is the action potential. So from phase 0 to the half of phase 3, this is the phase 3, this right here is the half of phase 3. So from here to here is the time period of the absolute refractory period. Clearly, and from half of the phase 3 to the phase 4 is the time period of the relative refractory period. Clearly, that's what I have written here. Absolute refractory period extends from phase 0 to half of the phase 3 of action potential, while as the relative refractory period, it extends from the second half of the phase 3 to the phase 4 of the action potential. Clear? Now we have the duration. Normal duration of the absolute RP is equal to 0.1 to 0.2 seconds, while as the normal duration of the relative refractory period is 0.05 seconds. Clearly, this graph 1 right here is the ventricular action potential, as we can see from phase 0 to half of the phase 3 is the ARP, and from second half of the phase 3 to the phase 4 is the RRP. Clear? These are the two types of the refractory period: absolute refractory period and relative refractory period. In the absolute refractory period, clearly cardiac muscle does not show any response no matter how hard the second stimulus is, while as in the relative refractory period, cardiac muscle shows the response if the second stimulus is of maximum intensity. Clear? Here is another graph. This graph is between time and force of contraction of the heart. Clearly, as you can see, from 0 to 0.2 seconds is the duration of the absolute refractory period, is the duration of the 0.1 to 0.2. So here 0 to 0.2 seconds is the duration of the absolute refractory period, and in this the cardiac muscle is contracting and we cannot re-excite this contracting cardiac muscle. And from 0.2 to 0.25 is the relative refractory period. Clearly, so this is the graph between the force of contraction and the time. Clear? Showing the ARP and RRP. This was the physiological characteristic number 9th. Now we move on to the physiological characteristic number 10th, that is the last physiological characteristic. It states that cardiac muscle does not fatigue. Meaning that heart in a healthy individual, it beats for life. It beats for life without getting tired. It does not get tired. Clearly, what are the reasons why cardiac muscle does not fatigue? Reason number first is the cardiac muscle has long refractory period. We saw in I taught you what this long refractory period is. So due to this long refractory period in the cardiac muscle, this cardiac muscle does not fatigue. So due to this long refractory period, cardiac muscle cannot be tetanized. Now what does this tetanized mean? Tetanized means phenomena of sustained contraction. Clearly, so heart muscle cannot be tetanized. Heart muscle cannot go sustained contraction because of the long refractory period. Clear? Because if heart goes under the sustained contraction, the person will die. So we cannot afford the tetany. This tetany occurs in skeletal muscles. You may have seen in bodybuilders, some bodybuilders undergo sustained contraction. So we can afford, if the skeletal muscle goes into sustained contraction, it's fine. We can reverse it. But if the heart muscle goes in sustained contraction, the person will die. So cardiac muscle does not fatigue. Clearly, because of the long refractory period. Second reason is cardiac muscle has rich blood supply. Due to this rich blood supply, cardiac muscle does not fatigue. Clearly, capillary density of cardiac muscle is 4 times than of skeletal muscles. The capillaries in cardiac muscle is 4 times more as compared to the skeletal muscles, which shows the high blood supply in the cardiac muscle. Clearly, and the reason number 3rd is cardiac muscle is rich in mitochondria. Mitochondria is the powerhouse of cell. Almost 33% of the weight of the heart is because of the mitochondria. So because of this mitochondria, the cardiac muscle does not fatigue. And the reason number fourth and the last, cardiac muscle undergoes aerobic metabolism. Cardiac muscle goes aerobic metabolism. Due to this aerobic metabolism, there is no accumulation of the lactic acid. There is no accumulation of the lactic acid. This accumulation of the lactic acid is an important factor for the development of fatigue. As lactic acid doesn't develop in the as lactic acid doesn't accumulate in the cardiac muscle, so it does not fatigue. Why does the lactic acid doesn't accumulate? Because heart undergoes aerobic metabolism. Lactic acid accumulates in skeletal muscles. It accumulates in skeletal muscles because sometimes they undergo anaerobic metabolism. That's what I have written here. Lactic acid accumulates in anaerobically exercising muscles, an important factor in the development of fatigue. This accumulation of the lactic acid is an important factor in the development of fatigue. So these are the 10 physiological characteristics of cardiac muscle. Thank you very much. Keep revising, keep studying. Like this video, share this video with your mates, comment on the video. Thank you very much. Your Dr. Ogwe here.